Hi, you're welcome. Welcome to my channel. Alright, so in this video we are going to solve a question under matrices. Okay, so this is a question that comes in paper 2. Alright, so let's see how we can solve this question together. Alright, so it's saying that it is given that matrix P is equal to the 7x, negative x, 2, negative 2 and 1. All right, then we are asked to find the value of x for which the determinant of p is negative 10. So this question came in 2023. Okay, so let's solve it together. So now, how do you find the value of x? Okay, how do you find the value of x when you are given the determinant? Okay, so you are going to use the formula for the what? For the determinant. And the formula for the determinant is equal to major diagonal, okay, minus minor diagonal. Okay, let me put it like that. Major diagonal minus minor diagonal. Now you'll be wondering, what is major diagonal and which one is the minor diagonal? So the minor diagonal and the major diagonal, this is the major diagonal. Let me label the major diagonal in a red ink, with a red ink. Okay, so this is the major diagonal there. Then this is the minor diagonal. So it is the multiple of what? The major diagonal minus the multiple of what? The minor diagonal. A multiple meaning that you are multiplying two numbers. So what I mean, these numbers, you are multiplying them. This 7x times that. Okay, so that is the major diagonal. Then the minor diagonal, you are multiplying this times that. Okay, so the major diagonal. So now let's find the determinant. So we said that determinant is equal to major diagonal, which is this one, 7 times 1. So mean that it is 7 times 1, right? 7x. So I should say 7x, okay, times 1, like that. I hope you are able to see. So there should be a difference between your x and your times, like that. 7x times 1. Then there is a minus here. Minus, what is the minor diagonal? This is the minor diagonal. So meaning that we are going to multiply this. Make sure that you put a bracket, because I'm putting the bracket as well. So negative x, it is negative x multiplied by what? It is multiplied by what? By negative 2, like that. Okay, so that is what you are supposed to do. So now in the question we have been told that for which the determinant of P, the determinant of the matrix P is what? Negative 10. They have already found for us negative 10 as the determinant. So we are putting negative 10 here. Okay, it's going to be negative 10. All right, so now this is just an equation that you can multiply, subtract and add. So we go on, we say negative 10 is equal to 7x times 1. It is going to be 7x. Then this negative, you multiplied it, we use this negative times everything that is inside. Okay, so that is what we are going to do. So firstly, what you are supposed to do is you copy it the way it is. It will be like this. So this is negative x times negative 2. So negative times negative, it is going to give you what? Positive. Okay, it's going to give you positive. Then x times 2, it is going to be what? 2x, like that. Okay, are you able to see? So from there now, you're going to say negative 10 is equal to 7x. Then you're going to multiply the negative times what is inside the bracket. So to be negative times positive, it is going to be negative 2x, something like that. Okay, you know that these are like terms, so you just say negative 10 is equal to 7x minus 2x. You're going to have 5x. Okay, so you need to get rid of x to find the value of x. So you're going to do over 5 like that. Then x will be 5 into negative 10. You're going to have negative 2 as your answer. So you have found the value of x. That is the value of x. Okay, so you found the value of x. So now suppose you are told to find the inverse, or the next question they are going to ask you, hence find the inverse of what? Of p. Hence find the inverse of p. That is the question. Hence find the inverse of p. So how do you find the inverse of p? Hence find the inverse of what? Matrix P. So the first thing that you are supposed to do, it is just to substitute the x that you have found in the matrix. Okay, so this is our matrix P. You copy it like that. Then where there is x, you substitute negative 2 inside. So it will be 7 multiplied by negative 2. Then there is minus 2. Then there is negative. What is our x? Our x is negative 2. Something like that. Then here it is something like this. Okay, so from there you're going to say p is equal to 7 times negative 2. You're going to have negative 14. Then negative times negative, you're going to have positive 2 like that. Okay, then from there you just copy negative 2, then 1, something like that. So that becomes your matrix P. Okay, that becomes your what? Your matrix P. So now what do you do next to find the inverse of P? What do you do to find the inverse of P? So now this is where you find the adjacent, what we call adjacent of P. Okay, adjacent of what? Of P. So now what is the adjacent of P? What is the adjacent of P? How do you find the adjacent of P? So what you do is, this is the major diagonal of the matrix. Okay, so the major diagonal of the matrix, these numbers, you need to exchange them, to exchange their sides or their position or their areas. So this one will come here and this 14 will come there. So meaning that it will be 1, then negative 14, something like this. So that is how you are supposed to do it. That is the first step if you are trying to find the what? The adjacent of P. Okay, so the next thing that you need to do are those numbers that are in the minor diagonal. They are supposed to exchange their signs. If this one is positive, if this one is negative, it becomes positive. If this one is negative, it becomes what? Positive. But this one is positive, it becomes negative. I hope you are getting it from there. Okay, so that is how you are supposed to do. That is what you are supposed to do. Okay, then the next thing now, that is when you find the what? The inverse of P. Okay, so the inverse of P, the formula of the inverse of P, you say that P inverse, it is like that. The inverse of P is equal to adjacent, okay, or it is equal to 1 over determinant multiplied by the adjacent. Okay, adjacent of what? Of P. That is the formula for the inverse. Okay, 1 over the determinant multiplied by the adjacent of P. So you're going to say P is equal to or inverse of P is equal to 1 over, what is our determinant? In the question they told us that the determinant of P is what? Negative 10. So you're going to say it is negative 10. Don't put the value of X here. Okay? Most of the students makes a mistake by putting the value of X under the determinant there. Then it is saying multiplied by the what? The adjacent of P. What is the adjacent of P? We've already found the adjacent of P. It is this. Okay? So mean that we are going to have the adjacent of P, which is 1, negative 2, 2, negative 14. Something like that. Okay? Something like that. So, most of the students put themselves in pressure by multiplying, they start multiplying everything like 1 over 10 times that. Okay? So, you can end from here. This is your inverse, and they'll give you full marks for that question. Thank you for watching. I've been your tutor, Patrick Divine. If you need tuitions, you can actually inbox me on those lines that you are seeing on the screen. Thank you.